Hello, dear viewers. Today, I want to show you how to design complete G+4 reinforced concrete building design in Autodesk Robust Structural Analysis Professional. So here is the workspace. So I want to create a new project. I will click new project, building design. I'll select the first option. So the first thing I would normally do is to make sure that I reset my preferences. Now, today we're going to work in is it called metric UK, that is 8110 PS 8110. I will go to tools. I want to change units and formats. So all my units and formats are in meters. Forces, kilonewton meters, others. I'll go to my force unit. I want to use, I prefer not newtons, but kilonewtons. Mass, I prefer kg. Then the unit is meter. And then I'll go to database or materials. British database, steel and timber. Steel and timber, we will change and just delete all these. Change to UK or Euro code, EC or Euro. Okay. And I'll go to standard loads, Euro code, building soil. Change to that. I want to leave soil data metric. Reinforced bar. And just add if BS, I think BS 866 to 205 is okay. And close. I go to design code, loads, BS 8110, BSEN for snow and wind, and for seismic load, EN 1998. Work parameters, I'll just click OK. Now, in this video, I want to design this particular building. It's a G+4. So there are many topics I'm going to cover. First is how to do the general arrangement in Autocad, or if you're an Autocad user, so you can use any. And I will show you also how to design halfway the model. Most of the time, you will be advised to design halfway the model because it will make your work faster and more accurate as compared to doing the entire model. This is a G plus 1, 2, 3, 4, because the roof, in as much as this is the roof level, this is a reinforced concrete slab, and therefore this building is a G+4 structurally. So this cannot be a G+3 because in as much as we have three levels, that is level ground floor, first floor, second floor, third floor. Okay, we have the roof level, but this is a G+4 because the top consists of a reinforced concrete slab and not the normal the normal floor, I mean roof joist or rafters, and the normal roof is a reinforced concrete slab, and therefore this is a G+4 building. And also you can see we have this water tank at this level, and we have the section and the we have this is a ground floor plan and typical first, second, third, and fourth floor plan. So I will model using these. I will usually model using these typical first, second, and third floor, and also the fourth floor plan. So I will just copy this, drag a copy down here. So I'll drag a copy from this point. Then I'll copy down, drag it down here. Okay, the next thing is to check our scale. Is this drawing to scale? To import is very easy. You can just go to insert, select PDF import, and then import. And remember to be able to import and edit PDFs, you need AutoCAD 2018 or higher version. So I'm using AutoCAD 2019, so I can easily be able to import and edit this PDF. So this is my drawing. And then I usually prefer to use specify insertion point on screen checked and then click, then place it whenever I wish. So I'll not repeat the process because it's a long process. So we need to check the scale. First, before you check the scale, we need to make sure that we are working in the correct working units, that is meters. So I'll type DWG units, type DWG units, and then I'll just click there to make sure that we are working in meters so that when I measure, I can be sure whether I'm working in millimeters or meters. So I'm working in millimeters because my unit is 3, unit for length is 3, as you can see here. So I just leave it as that. So we need to check the scale. I just go to linear. If I check from this endpoint, if you can't see the endpoint, you know how to use the snap endpoint. And then that endpoint should be 200 meters. If we measure that distance, it's far less than 200 meters, it's 0.006. So we need to scale this building. So I just select everything. I need to scale the drawing of the building. Then I'll go to scale. I usually prefer to use reference length. So I just select that point and use reference. From that is my base point. From that point, that endpoint, then I'll type my length, should be 200, and then hit enter. Now, this one is 200, but you can see our dimensions are very small. Now we need to change the dimension, the dim style. So I'll type dim style, then select dim style, and then you need to modify. I'll change the position to 0. That is primary unit. I'll go to symbol and arrows. I'll change this one to oblique. And then I will increase the arrow size to 150. And then I'll go to text and increase the text height to 150. I hope that is sufficient. And then click. So I prefer align with dimension line, then click OK and close. So this one is a bit, but a bit smaller compared to what we're observing here. So I will just increase the size again a bit more. Dim style, modify. So we reduce, I will increase the text height to 200, and the symbol and arrow I will reduce it to 100, and click OK and close. That looks almost perfect. So now that we have scaled our drawing, we can go ahead and luckily the architecture has included grid lines, but in certain scenarios you will need to add these grid lines manually. So how do we do that? Grid lines are always at the midpoint of walls, not columns. So if you have columns and you have walls, you need to draw grid lines at the center of each, or this center line of each wall. So normally you can just use a line, then click somewhere there, you draw a line and then make sure here perpendicular is checked, perpendicular, so that if I click at perpendicular, now I'm sure that line is straight, then I can just use Excel H, then at that midpoint. So if I go to midpoint is checked, I'm looking for this midpoint. So you can see that is my midpoint, okay? That is still the midpoint. So you'll do that for each wall, then you can trim your lines, then you use those lines as grid lines, and then you can change line time to grid line etc. So luckily the architecture has done the grid lines for us, so there's no need to repeat the whole process. We need just to check the because we don't have the grid line center to center spacing. So we know the wall is 200 millimeters, and then the space between these, because we have a wall here and a wall here, and this, because this one is there's no fill, it means there is no wall. So there's the distance between walls, and the thickness of a wall is 200. So I think this line is at the center, so this should be about 4,000. Then if you add this is about 4,000, because you divide 8,000 by 2. If you add that distance plus 100, then you get the distance from this grid line to grid line. By just using estimation, it should be about 100, and also here 100. So let's do the dimensions from this point. That point, that one is to 900. I'll go to annotate and then continue. 4,200, 4,000, 2130, that 900, 17, and 56. Now, if you notice, we are losing some dimension, because if you can see from this point, as I have said, if this one is 5,400 plus 100, the center of this wall plus 100, the center of this wall should be 5,400 plus 200, 5,600. But from at this particular point, we are losing some dimension here. And also this particular point, there's some difference. That is because the architecture was using Autocad and you're using Autocad. So the advantage is to anyone who is using Autocad to do the general arrangement, and they will get the exact dimensions as compared to the one who is using Autocad. But whatever dimension you use, because the difference here is very small, it will not affect your analysis. The design will still be the same. Okay. So if I go to Autocad, all I need is to go to minimize this, go to my desktop, and drag. I want to import that particular PDF. It's called Sophia Preschool. Sophia Preschool. So I can just minimize this one and minimize that, all those. I want to then I want to drag Sophia Preschool, drag it here. The first thing I'm sure is that the drawing will come with the correct scale. So if I just stop rebuilding, I just want to right click and then explode to current view, then okay, then I can delete. It's exploding to current view. Then you can just try to do the general arrangement using Autocad, and to get our dimension, see if you're going to get the exact dimension as the architecture has used, instead of getting those dimension with slight errors because of Autocad. So it's exploding to current view. So as it does so, I want to explain another concept, that is designing halfway the model. So before I do that, I'm going to show you something. So let me first go to this particular layer. I'll go to setting. Let me show you something. display lightweight, and click OK. Okay, then I want to just activate a polyline, change the color of my polyline to red. Let me first create a new layer. So right click, new layer. I'll name it polyline. Okay, or because I want to see it at the top, a polyline. Okay, and then I want to change that color. My color, I need it to be red. Okay, so I'll select by layer, then select a polyline. My color is red. Then I'll change the layer to, let's say, 200. No, 200 is too much. Let's say 100. Okay, I want to explain something about halfway the model. So I want to activate polyline. Then that point, so that you understand how you can do with different type of, because the building will not be the same shape as this, but you need to understand how you can do halfway the model accurately. So I'll go to that end, and I'll go up, and then I'll go this way, then that way. I hit enter. I can do this exact same. I can get the exact same shape on this side below, because if you check, if I can even just mirror, this polyline about. I'm not sure this one is a same line. Okay, I can just mirror about this one. If I select this polyline, let me select, and then I want to mirror about that midpoint. Okay, and then that way. No. Now, you can already realize there's an exact similar shape from this point, this lower side and this upper side. Now, to design halfway the model, we just need to consider one of these and the entire of this. Now, such that, and the entire of that, such that now halfway the model should be something. So if I go to my, because we did this building, to my model, this should be halfway the block. Okay, I think I've explained that. Now, I think we have, this one I displayed to current view. I'll just delete these, then you can continue to, I want to delete. Okay, this is already exploded to current view. All I need is to make sure that I check I suspend groups. So I want to suspend groups because that will give me issues. They don't need to be checked. Suspend groups. So it is checked. Now, we have this dimension, grid line to grid line, and we also have this other dimension, because if there is slight difference in this dimension, also we experience the same this way. So let's see if We have suspended groups if this is going to solve our issue. It's called Autocad. Just delete that. I want to just delete that. I want to copy these below here, these typical first and second floor. See if Autocad is going to give us something better without that difference. Then I want to drag a copy, right click, move, drag a copy. I'm not sure it's to scale. We can just scale it. There is no problem. So we have dragged a copy down here. Then I want to check the scale. So I'll go to Documents, Dimensions. The distance from this to that point should be 200. But on the contrary, it is not. So we need to scale this one. I'll just check arrow, then select everything. And then I'll go to scale. So I want to scale this one. So I just right click, and then I want to right click, and then I want to scale. So I'll go to edit, reshape, rescale. I'm used to this on the top icon, so I'm not finding it. I will rescale. From that point, Shift D. My new dimension should be 200. Hit enter. Now that is 200. I will change my option. I'll go to project preferences. I'll go to dimensions. I will change from meters to millimeters, to plain millimeters, and then click OK. Okay. Now I want to find the distance from grid line to grid line, and we notice the difference. So I'll click. Can I use that point? This number 2, that point. Number 3, that point. Then number 4, that point. Number 5, that point. Number 6, that point. Number 7, that point. And finally, number 8, that point. Then right click and click OK. Then I want to that point, that line, along that line dimension. Then you just drag it down or up. So unfortunately, we are facing the same issue as in AutoCAD. In some scenario, this will not be the case. All right. And we can just proceed to do a general arrangement using AutoCAD. If that is so, you can just confirm with the architect if you are getting the correct, if you're using the correct dimensions. So I can just, because we know what is our halfway the model, and just trim the remaining. Okay. Now if I select that and just trim to remove what is not important to me. Is it deleted or not? Just do that. Okay. Okay, either way, you understand. That is our halfway the model. So we can just work using that. So I'll just measure the center to center for this particular side of grid line. Although there might be a slight difference between the architectural dimension and your dimension, I think the design should be the same, because I think I'll go back to default. I think the design should be the same because the dimensions difference are just very small. So that point, then I go to annotate, continue. So I want to measure distance from wall to center line of wall to wall on this side. So my next, this is the beam, so I'll just use that beam. Sometimes the architecture is doing this because probably is how this design is not original, and he knows exactly where you should place your beam. So you are lucky your architecture has done this general arrangement for you, which is not the case in most scenarios. If you want to download this plan, you can just download down in my link. I have in my description, I have a link where you can download this particular plan for practice. Okay, so those are my dimensions. So after that, I can just turn off some layers. I'll go to home. I'll use this these off, turn off. Just turn off those. Okay, just turn off those. I'm sorry, I was operating where those are on, so no worry. And then we can measure the other side. So this one, linear, from this point to this point to 600, and then annotate, continue to that point, and then finally this point. Now we have another wall for our is it called our staircase. So we can just do create another grid line at this point using the method I showed you earlier. From this end, you make sure to be careful. If you don't see the nearest, it means you need to go to objects, nav object, then make sure nearest is checked. That is, there's a tick here, and I usually use nearest and perpendicular in this case, then midpoint when I'm doing the grid line. So I will create another grid line. Change my settings, go to others, I'll load which one? I'll load ISO dash. Okay. Then okay. By layer, I'll check ISO dash. Then XLV. Then I'm using a midpoint. So that is my midpoint. So I'll measure my distance from that point. I'll go to linear again. 5800. Then usually you use these, we call it rectangle to trim these continuous lines. Okay, right click. That point, just select, and then I can just trim. So there's no problem with that. Now we can just model halfway the model. There's no need to delete the other side as long as you have this for guidance. As you see, you have with the model. So it's this one plus this extra part. Next thing, I'll go to Autodesk. I'll go to geometry. I'll create axis definition. We're starting with, I think, is y-axis going up, and then z-axis is that way, and x-axis, because you have this axis, you make sure you utilize it. So I'll go to, I think z-axis is the one which is going up, right? Now we have our x, y, and x-axis. So I'll start with x-axis, which are definitely the same with AutoCAD. So going that way, starting I have added the first. The second distance is 2.9 meters. Then add. Okay, let me just delete. My second, the position is 2.9. Add. Number of repeat is just one because I didn't. Okay, make sure you change that to one. My second distance is the summation of that, and I think should be a distance of 2.9 plus 4.2. Not sure it's going to do the summation for me. Okay, so you need to be careful. So I'll double click, and then it is 2 point is 2. So just move backward or delete. I want to delete that particular. So 2.9 plus 4.2 is equals. So we are at 7.1. I just click OK. Then I think I'm getting it wrong. So I delete that one. For this one, my position of origin is 2.9. Okay. So this one need to be careful. 2.9. We are this 2.9. We are adding 4.2. Okay. 4.2. And then add should be at 7.1. We're going to repeat the same process. We add 4. We are at 7. We're adding 4. Add. We are at 11. We're adding 4.21. We're adding 4.21. Total of that. Sorry. Then we add that. We add 3.99. Add. And then we add that. We add 1.7. 1.7. And then add. We add that. We add 5.6. 5.6. Then we add. All right. So just like that, we move to the y-axis, and then we are starting at this point. Now this is our 0. This is our 0 here. So 0, we add that, we add 0, Number of repetition is 1. Distance is 0. We add. Now we're at 0. We add 3.1. Add. We're at 3.1. We add 3. We're at 6.1. We add 6.1 at this point. We add 3.05. 3.05. Add. And then we are at 9.15. We add 3.1. We add. We are at 12.25. We add 3 and then finally 3. So I'm going to add 3 twice. Add and then add. And then we can just click apply and then close. Okay, here is our grid lines. The next step is to model our columns. So you can precise the columns. I can send my Excel for that. But if you are an experienced person, you know this is a G+4 building. We need big columns. So I will use a column. This column at this interior point, I'm going to use a column of 250 by 350, and then here I just use 250 by 300. And then for the staircase, it's usually good that my column should not protrude because this area is very limited. So I just use 400 by 200 because my wall is 200, and I don't need my columns to be protruding outside the walls. I don't want to be visible in the staircase region. Also, I'm using 200 by 400 because this staircase is having a water tank at the top. Okay, so that staircase is carrying a lot of load from the water tank. So I will create my columns. I want to create reinforced concrete. The section by 350. By 350 because I want that. I'll just add, and then I'll add another 350. Material is class 25, C25. Okay. This one I will use 350. So 250 by 350, that is too big because I'm working in meters. So that should be 3.5. I mean 0.35 by 0.25 because I'm using meters. Then I will add, and then again the vice versa, 0.25, 0.35. I will add, and then just 0. I will add, and then 3.25. Then I will add, and finally 0.4, 0.2. I will add, and then 0.2 because you don't know the orientation. 0.4. I will add. So if I go to here, this is what I don't. We don't need that. Okay. So I'll start by this column. Try to place it there. It's facing the wrong direction, so I'll just undo. I'll change to 3 and 2.5. That point. Okay. And then just like that. I will change my column to 0.35, 0.25. Now we need to change the orientation. 0.25, 0.35. Now it is so important that you remember that we model these using which and which grid lines. We model these using these grid lines and this particular grid lines, but we did not do the grid lines on this side. Okay, so I will show you what to do in that case. So we're done here, then close. I will select all of these columns. I can go to edit. I will go to edit, then move copy. I want to copy in the negative y direction. Okay, so the x is 0, comma, negative y is negative 5.6, and then 0, and then execute. Then we having this one is at 1700. So I can just right click, select, and select this one, edit, move copy. This is negative 1.7. Execute. Select. I want to select this one. I want to change that column. I want to change the column here to be, let me try that one. No, that is the wrong, the other one. That is why I was creating, I was doing them, all of them anyway. And I can just right click, edit. I'll just copy, move copy. I want to copy about 2700, I would say 2700, 0, comma, negative 2.71, then 0, then execute. And I can just right click, select all of these. Is it 5800? Yes. In the x is 5.8, comma 0, comma 0, and execute. And that is our staircase. Then finally we have this area is our corridor. Now for using the Eurocode for schools, because this is a school, I think the live load in this corridor. Remember, corridors and balcony have a very significant live load. So the live load in this area should be about not 2.5, about 4 or 3.5. That live load is too much. So we cannot allow that to be cantilever. We need to have columns at this particular location to support this corridor here for students, because there's so many students playing around here. So we need some 200 column, that is circular column, because the column is just outdoor open. No, because circular will not hurt anyone, even as they go and collide and have some friction. It's just smooth. So we are having about 200 to 225. So I just come here, right click, select all of that, and then I want to move them by 0. negative 1.7, 0. And then I just want to copy, not move, execute, close. I will change those columns. I will create a new column. This time I want a circular 0 point diameter of 225 or 225. Okay, and add, close. You can just change those from this point. Now I can just close. I'll create column at that point, that point, that point, and finally that point. Now remember, this is halfway the model, so that implies that I'm not going to do this column as here, because this one here are just very small compared to the rest. It's just around 300 by 250 or even less can pass. But in this case, remember, this is halfway the model. There's another exact model, like this side, this top side, and at this lower side. So this column here are carrying a slab here and another slab here as this column. So the design you should use is for this particular two columns and beams in that case. So our model beams, I want reinforced concrete beam. I will start with edge beams, which are just, I think, 200 by 450 is okay. So that is 0.2 by 0.45 by 450, and then add. And then I will go with another 0.25 by 550, 55, then add. So I can just change this one to reinforced concrete. Start with this one. I can just click there inside, and then that point, that point, that point, that point, back, that point, that point. This column, the edge beams are not very critical because they are not carrying two slabs. So even these particular areas, I can just do the same thing from this. Okay. Console. I can just click the beginning from, that is my beginning, that point, another, that is my beginning, that point. It's being snapped at perpendicular. So those beams I can use to 50. The other beams for this, for example, this beam here, it is carrying a wall. You can see this wall and this slab and this slab, and as you can see here, we're having these partitions. So that is very critical. This is also very critical panel because this is the largest panel and this is the largest panel. So it's very critical. I think 250 for all this will be okay. For some, we need to use 600, even larger size of beams, but we are going to go to that later. because it is carrying a very large slab and another very large, because as you know, the load is usually transferred from slab to beam and finally to column and to foundation. So when the slabs are, the panels are very big, then the beams are very critical. They are carrying a significant dead load from those slabs and also are very significant. So you can go to 3D. Then if I check here, you can see our model. Okay, after that, I'll go back to plan. We can model our slabs. Okay, so again, I click there, then my slab should be 1.5 meters. Concrete, I want class 25 concrete, then add. No, I don't want to use the same label. 1.5 concrete, then add. Then we can change from here. We just need to click 3 points. So I will check rectangle, sorry. Okay, and then not point, I want to be careful when I'm modeling these slabs because although it will take me some time, I need to do it correctly. I'll just cancel that. That one. Now we don't have slab at this particular staircase region, but we have the staircase. The next thing I want to do is to go to geometry and go to stories. I want to go to, I will click stories. My top level is 2, let's say 2.8 or 3 meters is okay. Then I will add. So my building base level is 0. Define graphically the top level, let's say 6. Add. Top level 9. Add. That is story 1. Story 1 is 3. Story 2, story 3. We have the roof, 12. Add. And then we have the water tank, 15. Add. Then apply. Then close. So the next thing I want to do is to go to loads. Load, I'll start with load types, mainly dead, add, So it's added self-weight automatically, and then live, add. You can go to wind. It depends. So I'll go back to load definitions. I'll change this type to dead. I'll go to bar, surface. So we need to change this one from kilopascals to meters. Let me go to 3D. I'll go to tools, preferences. I want to restore default. Just change it on to millimeters. I want to go to force, others. So I want to go back to loads. Not sure it's going to work. We change these kilopascals. Kilopascals is if we search what is kilopascals, I think kilopascal should be kilonewton per millimeter. So let me try to search what is kilopascal, so that we don't get things wrong. You can just add. I'm checking my internet so that we can just quickly check what is kilopascals. So just let me buy internet. I think kilopascals is kilonewton per millimeters per meters. Okay, I think so. Should not get confused. So I'll go to amazing. I'm buying bundles, don't worry. Sorry. And two. Kilopascal in kilonewton. We are checking what is kilopascal, kPa into kilonewton per meter squared. Okay. So 1 kilopascal is equals to 1 kilonewton per meter squared. So don't get confused here. So I will add. I want to add in the direction of Z. So I want to add. Let me start by adding slab loads, or we can just start by doing the self weight of bars. I think self weight was added automatically. So that is self weight. So I'll go to surface. I'll start with surface load or a dead load of 1.5 kilonewton. Is it 1.5? Let's say 1.2. So we're having floor finishes and partitions. Okay, we're having floor finishes. Let's say finishes of 1.2 and partitions of let's say 1.3. So we can give it a dead load of 2.5 in the negative direction, kilopascals. Then add. Then I will apply to select, put it there, and then we have this freedom to just select using control. Okay. We are selecting all, and just right click and then select similar. Similar by, so I want to right click, select similar by thickness. Okay. So instead of wasting time, apply. That is 70-90, and then apply. So that was dead load. Then we go to load again, load definition. So I want to go to load. I want to change this window here from geometry to loads. Okay, because we need to add all other loads. If I click this load property, you can see our load is just like that, 2.5. Okay, I'm going to add now live load. Load definition, surface. Let's say a live load of, well, this is a school. I think you can add a live load of about 2.5 apart from our balcony. Okay, so we can add. I want to select apart from these balconies because we have a very critical live load. And apply. Then okay, I want to select add -3. -3. Add. I want to remove all those, and then we select manually. Okay. Okay. Okay, and then I can apply. Then I will add bar because I have a staircase and I don't want to model it. I'll add bar -z of -22. Negative, that is -22 for our double landing. And so this learning is not equal to, so I just add, I click inside delete tools, then select that one only, and I will apply. Then you can add another -12, add, delete, and I'll pick. Is it okay to pick that? So you can just leave it at that, and close. Right click, select. I want to delete. Don't need to use here. I want to select that support, or I want to go to geometry. Then I'll go to support or fixed support. Is this one fixed? All them should be fixed. All this should be fixed. Okay. All these should be fixed. Then you can just go to file and then save as. We need to save our model. I'll save it in my desktop, G+4. Just save it. We need to be saving our model because in any case, we can just recover. Okay. I think all are fixed. Right click, select. I can select, right click, select similar, by cross section, right select similar, not by cross section, by material. Okay. And then again, select similar by material. I want to select similar by material. Right click, object property. Okay, let's just I'll go to edit. I want to edit story. So go to geometry, go to story. Go to geometry. Close that one. So want to click story, copy content of story above, not the select item, just click OK. Now we're moving to story. Okay, story 2. I'll uncheck, right click, copy content of story above, okay. Right click. How you see I unchecked filter story, so just copy content of story above. So these are 1, 2, 3 plus the roof. So this is a story 4. I can go and then filter story. Okay, I want to filter story because this one is our roof. We don't have that much dead and live load. So I'll go to load, define load, surface. So I want to change, I'll go to loads, loads, define loads, surface. So if I let's go to geometry, story. Geometry, stories, filter story. Then I want to go to dead load. Okay, I have all those. So I'll go back to geometry, story, filter story. I can right click, select. Right click. So these are the live load. Yeah, I will change to 1.5. And then, I mean, the dead load, I just change to 1.2 or something like that. And then for live load, so I'll go to geometry, filter. I'm doing what I just did. Dead load, live load. So for the roof, the dead load and live load can be different. So just filter story. Or just do the analysis like that. Now for me, I'll just select Right click, select all these columns. No, just select the columns and beams. Geometry, story. I'll go to geometry, geometry, story, and check filter story. Well, I need to copy. Then I need to go to geometry. So right click here, sorry for that, and then copy content, one story above. Then I can go to beam. I quickly model my beam, 250 by 450. Okay. Quickly model my slab, rectangle. We have a water tank. Yeah. So this water tank, let's say I have a 10 liters water tank on top of this. So 10 liters, we know the gravity of water is 1. So 10 liters is approximately 10 kgs. Okay, 10 kgs. So 10 liters is 100. 10,000 liters. This is 10,000 liters, and then 10,000 kgs, and then 100,000 kilonewtons, because you multiply by 10, and then divided by 1,000 to get the kilonewtons. You get 100 kilonewtons. 100 kilonewtons divided by this area of about 6. So if you multiply, if you do the calculations, if I use the calculator, I have 100 kilonewtons divided by, let's say, if you can do the maths, 2.7 multiplied by 5.8, you're getting the answer to be about 6. So that is should be our dead load here. So beside that, these I can't just model this water tank beam like that. We need another intermediary beam here. So water tank is here very critical. We can't just do it like that. So I will go to loads, load definitions, surface. So I want to go to loads, load definitions, change dead load on surface -6. Acting in the global, I'll delete all those, and then I want precisely on that surface, that particular surface, then apply. So I will not add wind loads in this video. We're going to do the wind because the video has become too long. We're going just to do the wind load in the next video. So the next thing I can do is to save my model. Then do the analysis type. So we need to go to loads, auto combinations. Then I'll click that. Okay, I'll go to manual combination generate. I want to create manual and then go to more. Then you will see accident, uncheck and accidental. The cases uncheck wind. We are going to include the wind in the next video. Groups for dead, for live, for wind, there's no wind, relationship, live, next. So these are the cases. I just check all on and then generate. And then I'll click generate. Click generate. So we have generated the load combinations. And I'll go to analysis. Analysis type, you can just check if we have all these combinations. You can just do, you can see we have these combinations, all right? Linear combinations, then calculations. Okay, close. We have generated the mesh. And go to analysis. So the meshing, I think meshing is done. You can change the meshing options here. Results, you can check your results here. So I'm not going to go deep into analysis. We're going to do that maybe in the next video. You can go to design. You can designing beams and then columns. So just click any beam, select any beam, perhaps that beam. So that beam, and then go to design, provide reinforcement, and using manual combination, and then click OK. So you can see the diagram, you can see the reinforcement. And you can see the reinforcements required here. We can go back to structure. Can select one continuous beam, maybe that beam or even that one. Then design, provide reinforcement using, can use simple cases. I want to use manual combinations, then okay. Okay. And these are the required reinforcement. Remember, we have not added any partition wall load. So 12 is okay. That is D12 or T12 is okay because it's just carrying the slab. There's no partition apart from this. Maybe you can check the staircase area where we're having the staircase load. Provide reinforcement. I think also there tutorial double because the span is too small is okay. Now when it comes to column, you need to be careful. This is the diagram and reinforcement, the reinforcement required, and then the beam nodes. You can see the nodes where you can print this node. For columns, you cannot just design like that with the generated manual combinations. So for example, if I select this column is very critical, and go to design, provide reinforcement. Something is going to provide using this manual. I'm not sure, I don't think so. So there is no results, there is no, because it can't work with the manual. You have to do the combinations using manually. So maybe simple cases, but not combinations. And you can't also design using those simple cases. So there is no analysis, there is no nodes. The nodes are there is no reinforcement. So you need to go to combinations, loads, and create manual combinations. So you need to create manual combination. You need to delete all these combinations and create manual combination. So maybe that is something for the next video. I will end this here. Thanks for watching. Please consider to subscribe. I will see you in the next video.